All right, here we are. Notes week 2, part 1, where we are solving equations. And so over here, there are a lot of different techniques, and so you've seen these. This is sort of an overview of all of them. But we're going to complete the square, we're going to solve by factoring, use the quadratic formula, and the discriminant, which is related to the quadratic formula, and solve some rationals where variables are in the denominator as well. So question number 1, start out with some basics, and yeah, this didn't come out, the color didn't come out, but whatever. So I subtract 7 from both sides, divide both sides by 2, we get a solution. This is the value that works in the equation. Alright, straightforward. Number 2, so we have some fractions involved here, and here's kind of a trick that you may or may not know, but when we have fractions, you can look at the common denominator, and so the common denominator for all 3 of these terms would be 10. You can multiply the entire equation, meaning this, this, and this, every term by 10. So look at what happens. It basically gets rid of all the denominators. Multiply by 10, multiply by 10, multiply by 10, we end up with 2x equals and 3x, and then plus 70. So this equation is very straightforward relative to this, and we got there by just multiplying both sides by 10. So what do we do? Subtract? Oh yeah, and then we get x equals negative 70. So no problem there, and we'll be using that trick, for example, here in number 3. So we have some denominators, some fractions. LCD is 4. So we're multiplying the entire equation by 4, meaning this term, this term, this term, and this term. We end up with 8x here minus 2x. Here the 4's cancel, x plus 1, and here 24x. Combining like terms, and then lo and behold, here's something that you've been solving since Algebra 1 or before. Subtract, divide, x equals 1/17. 7? Yeah, okay, sounds good. Number 4. So that same trick, only here we're doing this with some variables. Let's see if this works. Now, if this were gone, so let's do this. Alright, if that weren't there, then we could just cross multiply. But that's not the case. So, cross multiplying will not work. We're going to multiply each term, this term, this term, and this term, by the LCD, which is 3x. And let's see what happens. So 3x over x here, 4 times 3x over 3x, and 1 times 3x. So do you see how we're getting cancel? 3 equals 4 plus 3x. That's manageable. So x equals negative 1/3. Alright, so here's our question here. And this, so we're solving for x. We're not going to get an actual number, but this x is going to be in terms of different variables. So first step, we're multiplying both sides by cx to get rid of the denominator, and we end up with this. Ax plus b equals 3 times cx. And so when you have the variable in 2 places in the equation, and you need to get it all by itself, here's how we do that. We need to group them together. So I subtracted 3, I'll write this stuff. I subtracted 3cx from both sides. And I did another step here, and I subtracted b from both sides. Just how this ended up over here. And now that these are grouped together, we can factor out the x so that we can divide by that and get x all by itself. So let's say we grouped, that's a G, we grouped, we factored, and then we divided. And so this is how we do when x is in 2 places in the equation and we're solving for it. So we factored, we're going to divide both sides by that term, giving us, where to go? Alright, there we go. Dividing by a minus 3c, and so we get this. If you solve this a little differently and you didn't have the negative, we could change the sign, and this answer for x would be correct as well. Okay. So again, notice how that's not a number, it's in terms of other variables, but we have solved for x because x is all by itself. Similar here, we got no numbers. That's cool. So we're looking for x, trying to get it all by itself. I multiplied both sides of the equation by x squared, so we have f times x squared over here, and then over here the x squareds cancel out, leaving us with gmm. At this stage, I would divide both sides by f, and then we would take the square root and put a little positive here, so plus or minus square root of gmm over f for x. Okay, take half and square it. This applies to down here. Got a little crowded on this page, sorry about that. Okay, number 7, so I give us a hint, we're going to factor. So first, first we distribute, and then we will combine like terms and stuff. So we have 6x squared minus 6x equals 21 minus x, and I added x to both sides. Anytime you have this quadratic, okay, you basically want 0 on one side. In general, that's the most helpful thing if you're like, hey, I have no idea how to do this. It's a quadratic, get 0 on one side, try to factor. So that's where we are. Set up 2 parentheses, and I think this works. 6x squared, I got the 3x and the 2x. Could have been 6x and 1x, but I thought it through. And then for minus 21, we're going to have a 3 and a 7. One's going to be positive, one's going to be negative. So I think this works because our inners give us a negative 14x, and our outers give us a positive 9x, so those combine to give this, and it works. Okay, so from this we get 2 answers. 3x minus 7, we end up with this. And let me just review where that came from. What it means is 3x minus 7 is equal to 0, so we add 7 to both sides. And 3x equals 7, in which case x equals 7/3. So that's how we ended up with this. And similarly, ended up with a negative 3/2 for the other possible answer here. Alright, so complete the square. Let's review what complete the square means. So complete the square means we're gonna add something to this side so that it becomes a perfect square. So for completing the square, this is the situation where you actually move the number to the other side so we don't have 0 on one side. So it's the first step. I have subtracted 2 from both sides. And so I left a blank spot here. Because what I'm going to do is take half and square it. You definitely want to write that down. Take half and square it. That, if you have that in your brain for how to complete the square, it will help. So half of our middle term, and we square, and that's 4. So what it means is we're going to add 4 to both sides and add 4 to both sides. This is helpful because this is a perfect square. We could factor to this. Notice how the thing in parentheses after it's factored is the half. Is that always the case? Yep. This is always this, the half. And then over here we have 2. So when we're solving an equation, this is helpful to us when we can write something this way as a perfect square so that we can take the square root of both sides. We end up with x minus 2 is, and don't forget the plus or minus, this is how we end up with our 2 answers. So one of the answers would be x equals 2 plus root 2, and the other answer would be x equals 2 minus root 2. If we had more time and more space, we'd plug those in and check and that kind of thing, but we don't, unfortunately. You should do that on your own. All right, page 2. Whoa, look at all this writing. We can do it. All right, still solving for x. We have a quadratic. It says hint, use the quadratic formula. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. We plug in. Oh, nice, square root of 1. We like that. And we end up with negative 1 or negative 4/3. Turns out that was factorable as well. You might want to try that also. You don't have to memorize this. You look around the walls of the classroom. It'll be there somewhere. But you do know how to, have to know how to plug it in and deal with those square roots and stuff. All right. So the discriminant, I went ahead and solved this just by factoring, factoring is the easiest way. So I moved these things over, I subtracted, and then and I added. So this is a mistake here. So let's forget about this. This is probably wrong. All right. So subtract 6x, add 9. And let's see where we go from here. So this would factor 2. We factor out a 3, and we end up with this. And then, aha, good. So I thought it was weird as I was solving through this, because this is not going to be factorable. We need these either a negative 1, negative 3, or positive 1, positive 3. So we cannot factor. Cannot factor. So the hint I had here in the notes was to look at the discriminant. So I thought that was strange. This is going to be wrong, though, because I subtracted instead of added the 9. So when we're looking at the discriminant is this part of the, zoom way in, it's this part of the quadratic formula. All right, so this is the discriminant. Doesn't sound like a good thing, but it tells us information. So if the discriminant is positive, we know we have 2 real roots. If it's 0, we know we have 1 real root, and by root I mean solution or answer. And if it's negative, we have no real solutions. And that's the discriminant right here. So make note of that in your notes as you would, and let's see what happens here. So our discriminant, we have, this is A, this is B, this is C. So when we have square root of B squared minus 4AC, this is going to become B squared minus 4AC. Yeah, that's where I messed up. So 36 minus 108. I think that's 108, yeah. So that gives us a negative number, which means no real solutions. All right, so we'd get to here, we'd be like, cannot factor. We could check in the discriminant and realize that there's no real solutions. You could also try completing the square, and you'd get the square root of a negative number. So our answer to this would be no real solutions. Sorry about all this jibba jabba. And number 11. Okay, rational expression, variable in the denominator. So what we're going to do, here's our LCD. We're gonna basically convert everything to that. All right. So first term, I'm multiplying by x minus 3 over x minus 3. Second term, multiplying by x over x, and then the 4, we have to deal with the 4, it's part of the equation, gets multiplied by the LCD over the LCD. So we have here's our LCD, we got this in the numerator, we got minus 12x, and we have 4 times x times x minus 3. At this point, notice how the denominator just disappears, okay? You can do that because what you're actually doing is multiplying both sides by the denominator, and 0 times anything is still 0, so that's out of there. And we have a much simpler equation where this is just numerator from up here. Combining like terms, gives, we got 4x squared, and I think, let's see, minus 24 plus 10 minus 14x. I'm all worried that I'm making mistakes now. Minus 30 equals 0. I factored out a 2 from everything. And then here, I think this is factorable. 2x squared minus 7x minus 15. Where'd that go? Okay, right here. So that can factor to this. We had 2x squared, what was it? Minus, 3, 10, minus 7x minus 15 equals 0, okay? So that's factorable to this, in which case we get x equals negative 3 halves and x equals 5 as our two answers. Alright, so we got some factoring in there. We have this rational expression where we converted to LCD. You could just multiply each term by this and you're going to get the same thing. Tough stuff. Okay, so here's our radical equation. We got square roots in here. And when you have the square root, you want the square root all by itself. And then you square both sides. Square both sides. So, if we look at what I did, I subtracted 1 from both sides first. The square root's all by itself. Now we can square both sides to end up with this. I multiplied out. I moved everything over, and then so that we have 0 on one side, and then factored and ended up with two solutions. I know that was quick, but that's how that works. So square root equation, you get the square root all by itself, and then you square both sides. So same thing's happening here. Square root equation, I'm going to add 1 to both sides and end up with this. At this point, I can now square both sides to get rid of that square root sign, and we end up with this. Like the previous example, I'm going to expand out. So I multiplied this, moved everything over, so subtracted x from both sides, subtracted 2 from both sides, tried to factor, lo and behold it worked, and I end up with x equals 7 and x equals 2. So again, I know I'm moving quickly here, but we are running out of time. And lastly, so for 14, you have to recognize something here, and what you need to recognize is that we have a fourth root and a square root. So x to the 1/4 times x to the 1/4 is x to the 1/2, right? We would add exponents. So x to the 1/4 squared is the square root of x. So this guy right here is x to the 1/4 squared. So what I did is I rewrote the original equation in terms of x to the 1/4, so you can see that this is like a quadratic that is actually kind of easily factored. I know that with this 1/4 exponent it looks crazy, but you could factor this, x squared minus 3x minus 4 equals 0, okay, which is essentially just what happened here. And so we get two solutions from this. We move down to this, fourth root of x equals 4, in which case we raise both sides to the power of 4, giving us x is 256, 4 times 4 times 4 times 4. And then over here we end up with this, which, you know, you're not going to take the square root and get a negative, so even root cannot be a negative. If you were to just sort of raise this to the 4th and raise this to the 4th, you'd end up with x equals 1. But if we check that in the original equation, we would get this 1 minus 3 minus 4 equals 0, which actually doesn't work. So in general, when you have square roots in an equation and you end up squaring both sides or something like that, or raising both sides to the 4th, you want to check in the original equation. Okay.